So now we're going to formalize the whole framework of hypothesis testing, and we'll start by discussing when can we even use this. So I like the analogy, and this is basically an analogy come up with by Cassie Kozyrkov, who was Google's first chief decision scientist. So this is much more of a data scientist way of looking at hypothesis tests. And this says that before you do anything along these lines, you need a default course of action. This means you need to have some game plan that you're happy to follow as long as you don't have any data, or you know very little, or the null hypothesis is true for sure. As I put on the top, I'll put the caveat that the whole hypothesis testing framework we're covering in this class is called the frequentist hypothesis testing. There is also a viewpoint that looks at this from a Bayesian point of view, and that's out of the scope of this class. So at least from the frequentist point of view, we really need this default action to start. Let me give you some examples. So I will point out that this is typically a really hard part of the problem, and it does require domain knowledge. This should be the responsibility of the lead on the team, whoever is asking you to run the test or deciding that a test needs to be run. But there are some situations where we have the default is considered to be fairly obvious. Cases where innocent until proven guilty. So we don't convict if there's no evidence. When we're testing new medications, the default is don't approve if there's no evidence. For scientific publications, the default is don't publish if there's no evidence. So those ones are fairly straightforward. But in different business applications, it can be a little bit more challenging to discern what your default action is. But this is a very important step because if you don't have a default action, you should not be doing a hypothesis test. So there's a lot more about this in the article linked here that was written by Cassie Kozyrkov, and so I recommend you link to this if you want more information. In addition to needing a default action, you need uncertainty. So hypothesis testing is not the same as data analytics. You can get some data and want to answer things like what's the mean, what's the standard deviation, what's the variance, what's the distribution. That's great, and all of that is really useful, but there's no need for a hypothesis test because there's no uncertainty if you are just looking at the data that you have and you want to make conclusions just about that data. The step of hypothesis testing comes in when you have some data and you want to make conclusions about a larger population. So maybe you want to use the data to infer something about the population, or you want to use two samples to infer whether or not they came from some unknown shared distribution. Those are examples where there's some uncertainty involved, and then a hypothesis test is a useful tool. So in general, once you determine you've met the criteria for hypothesis testing, the main steps are to define the null and the alternative hypotheses, to choose a significance level. That's the cutoff probability after which you will decide your null hypothesis is inconsistent with the observed data. Choose a test statistic to help you measure the discrepancy between the null and the data. Simulate or calculate directly when possible the distribution of the test statistic under the null hypothesis assumptions. Gather observed data and compare to the null hypothesis predictions. Compute the observed statistic and the p-value from the real sample. And if the p-value is less than the significance level, reject the null, otherwise fail to reject the null. At the end of the day, this framework just gives us some guidance as to whether or not we should continue with our default course of action or should change our course of action. It does not prove anything definitively. There is always some uncertainty. That's the reality of the game here. So we're just doing the best that we can with the data that we have. For a visual of these last few steps, these are examples of two different distributions of two different test statistics under different null hypotheses. And here are, for example, the observed test statistic from the data. And if we have such a situation as in the one on the left here, where low test statistics support the alternative hypothesis, then to get the p-value, we're starting at the observed and we're looking to the left. In contrast, if we have a situation where high test statistics support the alternative, then we start at the observed test statistic and look to the right. At the end of the day, then the yellow area here is going to denote the p-value. So these are two different scenarios, two different test statistics, and basically two different alternatives. And now we're going to go through step by step in individual videos some key things to consider, for example, when defining the null versus the alternative, or when choosing a significance level, or when choosing a test statistic, or when calculating your p-value and making your conclusions. So the next videos are going to deep dive into each of these separately to give you a little bit more intuition about these separate steps.